All right, this is going to be an LP360 tutorial. Today we will be processing data collected from the TrueView 1 with the 26 megapixel camera. And the version of LP360 that we are using is version 25.2 To get started, we're going to go to the Sensor tab and we're going to press Cycle Import. Here on the raw mission import wizard, our import mode is going to be import flights into new project. And then under sensor, we're going to select TrueView Microdrones TerraDrone. Then next. Here we're going to import our raw cycle folder. So we're going to press folder and we're going to go find our raw cycle file. Okay, I'm just going to left click once, then press select folder. Then I'm going to press next. And on this screen, we're going to go find our Rhinex file. Click next. On this screen, we're going to set up our output location. First thing we're going to do is set up our root folder. So basically where we want to save this project. And we're just going to call this True View 126 megapixel. And last but not least, we need to set up our CRS, our coordinate reference system. This project was flown in Tennessee using the Geoid 18 vertical model. NAT 83, 2011, Tennessee US foot, North American vertical datum, Geoid 18 US feet. Next, double check everything here, looks good. Everything looks good there, and we can go ahead and enter our survey nail right here. Now I did an Opus solution, so I'm gonna go find my Opus. And we're just gonna call this True View 1 LP360 demo. All that looks good. Finish and yes. Everything has been imported into LP360. The next step is we are going to create our flight lines. There's a couple different ways we can do this. We can either do this via the Auto Create Flight Lines tool, and we can also do it manually. So to create this using the Auto tool, I'm just going to press Auto Create Flight Lines. And then we're going to use the geometry-based method. I'm going to input my minimum length, my turn radius, and my maximum deviation. Select Compute Flight Lines. Click Next. And we can see that did a pretty good job. All we want are these parallel lines. We don't want anything in our turns. All this looks pretty good. So I'm just going to hit close and we're ready to go to the next step. Now to do this manually, we're going to turn on our trajectory points. We're going to come over here to our Select Edit tool. And I'm going to choose Select Edit Polygon. And I'm going to zoom in to where I want to start. Don't really want anything in the turns. So I'm going to start, say right there, and I'm going to left click, zoom out, come over here, left click again, zoom out, come down here to the end, left click, and when I'm finished, I am going to double left click. Last step, I'm going to hit manual flight lines. And we can see we now have our flight lines. Again, all we want are these parallel flight lines, so we need to edit this a little bit. So we're going to turn off our trajectory points and go back to my Select Edit tool. I'm going to choose Select Edit Lasso. I'm going to hold down my left mouse button. That's going to select the flight lines I don't want. I'm going to hit Delete on my keyboard. Select Continue. Then I'm going to go up to my Feature Edit tab. And then we're going to select Save Edits. And that is how we can create our flight lines manual. And we're going to now select trajectory processing. We're going to select single base. My processing is done in the cloud, so I'm going to select cloud. Oops. Single base. Select next. I already have my survey nail entered from the Opus solution. Got a Ronex file ready to go. Select next and submit. Go ahead and click yes. I can click Job Manager. See, this has been submitted to the Job Manager. And I can close this and go to the next step once I have the notification from my Job Manager. All right, we can see here in our Job Manager that the trajectory processing has completed. So we're going to go ahead and open our Job Manager. I'm going to left click on our completed job. Come over here on the right hand side. First, we want to view the report. And we're going to scroll down and go to GNSS-QC. See that we have 100% fixed. That's what we want to see. So check our PDOP. All PDOP values look good. Everything is under 2. And go ahead and close that out. Now we're going to go ahead and just click Complete Job and yes. Okay, it's going to ask us if we want to view our post-process trajectory report. We can go ahead and click yes there. Again, it's just going to be the same report that we already looked at. Close that. And now we can see that our post-processing of our trajectories has completed. Go ahead and close our Job Manager. And the next step is we're going to go to our geocoding. So for this step, I'm going to go ahead and leave clip range off. If I turn that on, I could clip out any data within a certain distance of the sensor. So for example, right here, you can see that I've got a minimum of 3 and a max of 150. If I left this clip range as is, it's only going to geocode the points between 3 feet and 150 feet from the sensor. I'm going to leave that off for now. Here's where I can set my clip angle. We're going to process 40 degrees from nadir. total 80-degree scan angle. We're going to enable true track, and we are also going to process our photos by updating our EXIF tags only within the flight lines. And last but not least, we're going to colorize our point cloud. Go ahead and click submit. Going to give you a notification that's been submitted to our job manager. Go ahead and open up our job manager, and I can see there it is processing. All right, so we can see here in our job manager, geocoding has completed. So we're going to open up our job manager, left click on the job, then select complete job, and yes. Go ahead and close this out, close our job manager, and boom goes the dynamite. We now have our point cloud. Come up here to the top, we're going to change our view to elevation and points to 10 surface. Zoom in, we can see our newly created point cloud. So from here, we'll be ready to run our strip adjustment. Then from there, our smoothing point cloud task, our accuracy assessment, and then begin our ground classification. So the next step is going to be our strip adjustment, and this is to ensure that our flight lines are lining up the way they should. Now we can do a quick QA/QC with our point cloud to ensure that we even need to run this. And to do this, what we're going to do is we're going to go up here to our view type, and we're going to select point source. And right here, we can see, changes the points. We see all these different colors. So these different colors are going to represent our flight lines. So flight line 1, for example, is going to be the blue. Flight line 2, green. Flight line 3, this pinkish color, so on and so forth. Now, the gentleman that flew this used quite a bit of overlap, which we really do not need nearly this much overlap. So instead of going back and, well, we got a couple of options. I can go up in my what's called our live view and change our scan angle, or we can just run our post-processing and just use a narrower scan angle, which is what we'll probably do. Now, this will also serve as a good time to check if we need to use our clip range. So what I'm going to do is we're going to go up to our immersive view. And if we zoom in, we can see that we do have some high noise. Let me kind of rotate it this way. There we go. Yep, all of this up here is noise. No bueno. We want to get rid of that. And the clip range is going to help us get rid of that. Should get rid of all of that. So what we're going to do is we're going to go to the post-processing option. And I'm going to cut my clip angle down to, we'll try a 40 degree. I mean, there's quite a bit of overlap right here. We do not need anywhere near this much. So we'll try a 40-degree scan angle, which will be 20 degrees nadir. And the clip range, let's take a quick measurement there. What I'm going to do is we're just going to come in and measure the ground with our flight line. So we can see our flight line right there. Obviously, there's our ground. So here is our measuring tool. So that's about 222 feet. I could probably easily clip out anything within 100 feet, and it's going to get rid of all this noise. So we're going to go back to our post-processing. Clip angle, we're going to try a 40-degree scan angle, 20 degrees from the deer. Minimal, we're going to say 100 feet, and didn't really see any low point noise. So I want to ensure that I do not clip out the ground. So I'm just going to put in 1,000. We're going to go ahead and update our EXIF tags, and we only want to retain photos within flight lines. Run post-processing, and we'll have our post-processed point cloud here momentarily. Okay, we can see that our post-processing has completed. We'll click OK. Going to close out of our post-processing window. And if we look over here in our table of contents, we can see that we have our post-processed point cloud. So I'm going to come up here and change our active LAS layer to our post-processed. And we're going to change this to point source. Let's see how our overlap looks now. So now the overlap looks to be closer to about 50%. Could probably cut that down a little bit more if needed, but I think that'll be okay. Let's check our immersive view. And we can see now we do not have any of that high noise. So let's go ahead and check our flight line separation to see if we have any, and if we do, how pronounced it is, and whether or not if we need to run our strip align. Try to find a planar surface. This should work over here. We'll change this back to point source. And we can see we've got some overlap. So we're going to do the same thing with our profile view. Up here in the top left-hand corner, I can change my view type. I want to view this by point source as well. And we can kind of see a little bit of separation right there. It's not too terribly bad, but there is a little bit. We also have a drape profile. We're going to run that by source. And if we zoom in, we can see here's our overlap. So there's flight line 1, the blue, flight line 2 is the green, flight line 3 is the red. And we can see that there is a little bit of overlap. I'm sorry, separation. And let's see if we can come over here. It actually doesn't look too bad. Let's see if we can run a couple other spots. Yeah, so we definitely have some separation. But nothing too terribly crazy. About 2/10. That's probably just the noise window, but I think it's enough we could justify running our strip align. So to run a strip align, we're just going to come up here to our toolbar. I'm still under the sensors tab. If I scroll over here to the right, I'll see our strip align. First thing I'm going to do is I'm going to select the point cloud we want to run this on. We want to run this on our post-process point cloud. We want to update our EXIF tags and also recolorize. So if we didn't update our EXIF tags or recolorize, we would have an offset between our colorization as well as our ortho if there is any sort of horizontal shift. Now the alignment doesn't look to be too dramatic, so I'm going to select small misalignment. And then now we are just going to give our new last layer a name. I'm just going to call this strip adjusted. We'll go ahead and submit that. It's going to submit to our job manager. And when this has finished running, we will get a notification here in our job manager. So it appears that our strip adjustment or strip align has completed. We look up here in our job manager. We're getting the notification. We are going to click on our strip adjustment line and complete job. Yes. Hit OK to add this new point cloud to our project. And if we look over here in our table of contents, we can see the strip adjusted layer, and it is our active layer here in our project. So we're going to go ahead and change this back to our point source. Zoom into a planar surface, and let's see our results. So this is the strip adjusted. And if we switch this over to our post-processed, we see a much better improvement. There's a road right here. Go ahead and just draw a line straight across the road there. We can really see that point separation. Turn our draping tool back on. There's the crown of the road. That separation is very clear. And we'll go to our strip adjusted. And much better. So the next step, we can go ahead and run our smoothing point cloud task. Before we do that, we can either import a border or create one. Now to import a border, you can import really any shapefile, KML, KMZ, through our import wizard. So to do that, we just go up here to our project tab, add files, feature, then we'll click the add button, which is going to be this green plus button. And here we would go find our border. Now I don't have one for this one, but presuming I did, let's say you've got a KML or KMZ. You would just find the appropriate KML or KMZ. Make sure that you transform that to your coordinate reference system for the project. And then you can go ahead and import it. Now, if you're like me and you don't have one, we can easily create one here in the project. To do that, we're going to go up here to Feature Edit, Create Feature Layer, Browse, and let's go find a spot where we can save this border. I'm just going to create a new folder. I'm going to call this AOI for Area of Interest. Get the keyboard to work. There we go. And then there, we'll get really creative and call this AOI as well. Save that. Here we can see our new feature layer name, and our geometry type is going to be 3D polygon. Select OK. If we look over here in the table of contents, we can see our new feature layer. I'm going to change that color to red, and to do that, I'm going to right-click on the feature layer, go down to Properties, change my outline color to red, and we'll change that width a little bit as well. To create the feature, I can see my new area of interest feature is the active feature layer. To the right of that, I have a Create Feature button. I'm going to select that. And to create this, I'm going to left-click, 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 and when I'm done, I'm going to double left-click. There's my new border. Don't forget to save your edits. So come back up here to my menu, click Save Edits, and yes. Next step is we're going to run our smoothing point cloud task. And what this is going to do is going to help eliminate noise around our surfaces, around our planar hard edge surfaces. So if we look here on our road, turn this off, we can see that we do have a bit of noise there. But when we run this, it will significantly improve the amount of noise that we are seeing on our in our point cloud. It's not going to delete any points, anything like that. It's not going to affect the vegetation. Again, where we're going to see it is going to be on our hardscape. So to do that, we're going to come up here to Point Task. And in the drop-down menu right here, I'm going to select Smooth Point Cloud. Next step, we're going to go here to Active Point Cloud Task Settings. And here, I'm just going to go from top to bottom. Feature Geometry. I'm going to hit the ellipsis right next to that. The drop-down menu, I'm going to select Shape Layer. And then go find our border, that area of interest right there. Another option is I can leave this as tool geometry. And when we execute it, right up here, we can execute this by feature layer. So it really doesn't matter. I can either leave this as tool geometry, execute by feature layer, or I can change this to shape layer, change this to my border, and when I execute this, we'll execute it by active layer, and it will execute it within that border. Again, doesn't matter. Next step is we need to tell it our source points. First is which point cloud do we want to run this on? So I'm going to hit the ellipsis right here. Second ellipsis down. I can see I need to enter the LAS layer. And I'm going to go find that strip adjusted. There it is right there. Close. Now we need to tell it what filter do we want to run this on. Now this has not been classified yet. So we can just select created, never classified here in the drop-down menu. Or I can select all points. It's not going to matter. Again, nothing's been classified. So 6 one hand, half dozen in the other. All points. That looks good. Okay. Now we need to tell it where do we want to save this point cloud. We're going to be creating a new LAS layer. So we need to set up the location where we want to save this. Now to do this, I'm going to highlight this window right here. We're going to delete that. I'm going to come right up here in the top right-hand corner. Click that button, and it's going to take us to the project path that we created earlier. Now I'm going to hit the save icon. It's going to take me straight to my project path. And in here, we already have a LAS folder. I'm going to create a new folder. It's going to be called Smooth All Points. And click OK. We're going to add this layer to our map. Now, if I look over here to the left, we have all green checks. That lets me know that we have correct inputs, or we have inputs that will allow us to execute this point cloud task. Close. Very important, we always want to tile our files. So we're going to tile this. Each file size will max out at 250 megs. And then we're only going to output our smooth points. I'm going to hit apply. Close this. And then we zoom out a little bit. We'll see when we execute this, we will have our new smooth point cloud, but it'll be limited to within our project boundary. So to execute this, we're going to click by active LAS layer and yes. Okay, we now have our smooth point cloud. Looks like I inadvertently named that smooth ground. Let's see here. Let's just change the name. Where? There it is. Smooth all points. To import our check shots, we're going to go up here to the top. I'm going to click on our control points tab, import, add, and let's go find either our text file or CSV file. Here's a preview or import. I'm going to click next. I'm going to leave this as delimited. Next. Enter our delimiter, which in my case is a comma. Next. And here we are going to select a column for the correct point data attribute. So column 1 is going to be name. Column 2 is my northing. Column 3 is my easting. And column 4 is my elevation. Click finish. Okay, when I zoom out, I can see my check shots. So my next step is we're going to select accuracy estimation underneath the control points tab. Here, we're going to enter the workflow used to shoot our check shots. Here we connected to a local in-trip network. So I'm going to select real-time network rover. Hit OK. And in my quick set here, I'm going to select all and now auto find. Okay, so immediately looking at this, I can tell I have a bias. I have a vertical error of, let's see, 4.3 feet with an error, or I'm sorry, a mean error of 4.3 feet. Deviation of a ½ inch, a precision of right around an inch. Everything's going in the same direction, which signifies a systemic bias. So to correct this, all we need to do is click auto find. Now, this is only going to correct our vertical. If you actually have targets, we can zoom in, change our elevation to RGB, or we can use intensity. We can also make an adjustment that way. If I look at each of these, there's 100, there's 101, There's 102 and 103. I can see this also has a bias as well. They're all going in the same direction. Now that doesn't have the best resolution. We would normally use our ortho as a proxy for horizontal, but if you don't have an ortho, we can use the point cloud. So to correct our horizontal, all I need to do is check measure mode here in our control points report. And we're going to start with the first target, which is number 100. I'm going to zoom in, and we're going to click the center of the target. Do the same thing for 101. Click the center of the target. 102. Click the center of the target. And 103, click the center of the target. And here it's the same thing. Everything's in the same direction. Signifies a systemic bias. Just going to click solve. Give our output layer a new name. We're just going to call this, just call it adjusted. Or we could call it the bias. And then apply correction. If we look over in our table of contents, we can see we have our new LAS layer, our device LAS layer. So we're just going to click OK here, click yes. We're going to change our active LAS layer to our device. Come up here, change this to intensity. Change this to 10. And we're now going to drag and drop our point layer above our point cloud, and everything should line up the way it should. So we're going to run this one more time. Accuracy estimation, auto find. And that's about what we should expect. Not quite an equal distribution of error, but for this sensor, this is well within the advertised accuracy and precision. Do the same thing. We want to check our horizontal. To export our report, I'm just going to come up here to the top, export report. Give this a name. Let's call this accuracy report. And now we have our accuracy report. So we can see our first component error, our second component error, and then our product accuracy. Okay, with that, knowing that we have a good data set, we can go ahead and begin our classification, our ground classification. Clean up everything. So to do that, we're going to go to our point task. Here in the drop-down menu, we're going to select Create Seed Surface, Active Point Cloud Task Settings, and then similar with the previous point cloud task, we're just going to start at the top and work our way down. I'm going to leave this as tool geometry because we're going to execute this based on our feature layer. Now we just need to tell it which point cloud we want to run this on. Well, we want to run it on the device. Cell size is going to be 30. We want the lowest point in each cell. And our destination is going to be ground. Oh, I forgot to set our input. Our input is going to be created, never classified. going to just click apply and close this out. Come up here and we're going to execute this by area of interest. Again, we only want what's inside that area of interest. Okay, that task has completed. Just click OK. And then here in our filter, we're going to select ground. I'm going to select elevation, leave this as 10, and we're going to force 100% resolution. Now, if we go ahead and turn on our contours on the fly, you see we already have a very crude surface that's beginning to generate, that's been generated. And what we want to do now is some of these areas over here, I don't know if those are high points or low points. We just want to double check that and make sure that that is actually the ground. Something else. What we're going to do is we're going to draw a profile line just across this area right over here. And this filter. So our source is going to be ground. I'm sorry, our filter is going to be ground. Source is going to be all points. And we're also going to have classify non-visible points selected, which is going to be this icon right here. And destination, we're just going to send this to low point, number 7. So to reclassify these points, we're going to classify below the line. So I'm going to select this icon right here. And if you watch, now that I draw a profile line, and all I'm doing is I'm just left clicking here in the profile window, I can actually see our non-visible points. So that's what we want to get rid of. It's that right there. When I'm done, I'm just going to double left click. And we're sending this to destination number 7. So I'm going to hit 7 on my keyboard. And that was reclassified. So we can turn our contours back on to help us a little bit. Got a couple other areas right there. Let's just go check those. There they are. Hit number 7. That's reclassified. Okay, now that we have our seat surface completed, we're going to go ahead and turn off our contours on the fly. Turn off our forced 100% resolution. And the next step is we're going to thin our point cloud. So to do that, we're going to go back to our point task. And our active point cloud task, we're going to select ground thinning. And then now our point cloud task settings. Oops. There we go, ground thinning. Okay, just going to leave that on tool geometry. We're going to leave this on meters. Remember, our active point cloud is the debias. So we're going to select debias. And our input points filter is going to be created, never classified. So our final point cloud is going to be between 8 and 10 points per square meter. For this thinning process, we are going to have about between 13 to 16 points per square meter. So what we're going to do is we're going to select the minimum, max, and median. I'm going to do 12 random. That's going to give me 15 points per square meter. And our destination class is going to be ignored ground. This kind of, think of this kind of like as a staging area, so to speak. Makes sense with the next step after this. So we're going to send this to ignored ground. We're going to hit apply. Go ahead and close that. And we're going to execute this by feature layer. Again, we only want the area inside our area of interest, and run. Okay, just click OK. And if we go to our ignored ground filter, you can see this is our thinned layer. Okay, so the next step is our iterations. Here in, again, still under point task. In the drop-down menu, we are going to select ground classification, perform iterations, and go change our point cloud task settings. Our input is going to be ignored ground. If I hit refresh, we'll see that we've got, maybe it's, what did we say, 15 points per square meter, which is a total of 737,000 points that we're going to be pulling from. And my destination is going to be ground. But we also want to set a key point. And the reason why we set this key point is if we run this task, we don't like the results, we can easily move those ground points back to ignored ground without affecting our seed surface. So we're going to set that key point. We've already generated seed points, so we don't need to do that. We're going to use our existing ground points only. Defaults to ground, so we just click OK there. And we're going to run this on the same seed sample distance that we did previously, which was 30 feet. Now, this next step, when we enter our angular threshold and maximum distance, there's really no one size that fits all. The more features that you have on your terrain, hills, rolling terrain, any sort of elevation changes, the higher your angular threshold needs to be. Let's say if it's flat as a pancake, you could have a really, really low angular threshold. But you have to be careful because even though, let's say if you have features that are covered by vegetation, if you get too aggressive with this, you are going to start classifying vegetation as ground. And we don't want to do that. So I usually like to start with a really conservative number. So we're going to start, say, maybe at 1 degree. And we're going to have a distance of 1 foot. We want to check omit edge climbing algorithm, and we're going to run 3 iterations. So what this is going to do is it's going to go to every seed point. So let's go back to our seed points, our ground. We'll just say this seed point, for example. So what it's going to do is it's going to extend outward on the X and Y plane by 1 foot at a threshold of 1 degree. Any point that falls within that threshold and within that distance is going to classify as a ground point. So by starting out with a really low angular threshold, that's going to all but guarantee we don't classify vegetation. Versus if I had, say, a 5-degree angular threshold or 10 degrees. We're going to start out with 1, see how that does, see how that works out for us, and we'll go from there. So I'm just going to hit apply and close this out. And we're going to execute by feature layer again. Again, we only want to run this in our area of interest. Okay, this has finished running. Let's go up here and change this points to 10 and let's see our results. We can go ahead and turn on our contours on the fly. Now this may be a little difficult to see. If you want to change the color of your contours, all you have to do is go over to your active point cloud, which is our debias. Right click, go down to properties, check symbology, contours, and right here we can modify the color. White usually jumps out really nice, so we'll change these to white. And we'll do 1 foot contours. And our shortest contour we'll say is 50 feet based on map units. There we go. Okay, so for the most part, that didn't do too bad. Main thing I'm looking for right now is any potential vegetation. Don't see any, looks pretty good, but we definitely have some areas that we need to clean up. I know there's like a hill or something over here. Looks like we got an area of interest over here we need to work on and some other areas. But good news is no vegetation. Able to get through that vegetation, we actually got down to the ground. So to analyze this, we're going to change this from 10 surface to points. And the areas that you can usually tell that are actually going to be areas that we need to repair versus vegetation are going to be areas that have a very pronounced border, like this right here, versus an area that is compared to say something like this right here. So I can tell by looking at this, this is vegetation. This is an area that needs to be repaired. This is probably a hill or a ditch or something. But we can just start over here. And first thing I'm going to do is I'm just going to draw a profile line across that. I zoom out. My filter is going to be ground. My source is going to be ignore ground. And we're going to turn on classify non-visible points, but this time we're going to do above the line. I'm just going to draw a line underneath there. And sure enough, as expected, that's the ground. Now to repair these areas, it's pretty simple. We're just going to run the exact same point cloud task as I did previously, but we're just going to make a couple changes. We're going to change this seed sample distance to 25 feet. And we're also going to generate seed points this time. Everything else for now, I'm going to leave the same. I'm just going to hit apply. Do this over here. But I don't want to run this on the entire data set, just these areas that need to be repaired. So we're going to execute this by polygon. So instead of by feature layer or active layer, I'm going to select by polygon. And we're going to draw a polygon around this area right here. I'm done. I'm going to double left click. And there we go. That is all that's to it. All right, there's some more low point noise that I missed. So let's go ahead and get rid of that. And draw a polygon around that as well. There we go. Okay, let's go ahead and do these others. I'm just going to start up here at the top. There you go. We can also use my envelope. And circle stamp. Now, some of these you may need to adjust your inputs a little bit. If you have, again, if the more pronounced the feature is, the steeper the hill, for example, the more the rolling terrain is, the lower your seed sample distance and or the higher your angular threshold will be. But again, the offside to that is if you've got a lot of vegetation, you run the risk of classifying vegetation as ground. I would rather start with a really low angular threshold, slowly work my way up, and let LP360, these bugs, let LP360 do the work for us, rather than classify a bunch of vegetation and have to go back and clean it up. So next step is, again, I mentioned earlier, our final data set is going to be right around 8 to 10 points per square meter. So what we're going to do next is going to go back to our ground thinning, go to our settings. Our input this time is going to be ground. And we can change this point size back down to large. And our destination is going to be our reserved model key points. I'm going to leave this at meters. We want the lowest, max, median, 5 random. That's going to give us 8 points per square meter. Just hit apply, and we can go ahead and turn off our contours. And let's execute by area of interest. Now, if we go to our reserved model key points, don't lose any resolution. And we're down to a manageable size of 8 points per square meter. Contours. Now, if you like the really nice cartographic curved contours, it's easy to do. All we need to do is just run the smoothing point cloud task again. So what we're going to do is let's just go ahead and turn off our force resolution, turn off our contours. And we're going to go back to our point task and go to smooth point cloud, go to our settings. Our input is going to be the reserved model key points. Our source points is going to be, we're still working off the bias. Set up our output location. And we'll create a new folder. We'll just call this smooth ground. Okay. And add this to map. I'll put only smooth point. Make sure that we tile. Apply. And execute. Okay, you see we now have our smooth ground points. We're going to change our active lines layer to our smooth ground points. Let's turn on our 10. Now we can turn on our contours on the fly. There we go. Okay, so to get ready for our deliverables, what we're going to do is we're going to go ahead and create an elevation model, then import that back in as a solid surface, which will be our grid file. We'll do a 1-foot grid. We'll do a final elevation check or a final control points check. And then we can go ahead and export our surface as well as our contours if needed. So we're going to go up to Project, Export Wizard. Export type's going to be Surface. Our input points filter is going to be the reserved model key points. Click OK. And we'll do a 1/2 foot. I mean, elevation model. GeoTIFF. Next. We're going to select cookie cutter by polygon. There's our area of interest. Name field's going to be ID. Next. finally set up a location where we want to save this elevation model. Insert output the map and finish. Okay, there's our DEM. We want to go back to Project, add files, DEM to LAS. Let's go find that DEM we just created. There we go. Then down here, I'm going to select an output location. There's our LAS folder. And this is going to be our grid file. And we can go ahead and set up our destination class as our ground points. Hit OK. And we now have our grid file, DEM LAS layer 1. No longer going to need this DEM, so we can right click on it. Just go to remove layer, click yes. And if you want, we can rename that DEM LAS layer 1. We can just name that grid file. And if we open up our immersive view, we can see we now have a point cloud with 1 point every half foot. Okay, let's do one final QA/QC with our control points. So here's our control points in our table of contents over here on the left. I'll left click on that, drag and drop it to the top. Can go back to, where is it? Control points. Accuracy estimation. Quick set as all, click auto find. And right where we were, I think it was 9/10. So pretty much right where we were, right at an inch. Okay, so to export our deliverables, we want to export a surface. We can go to Project, Export Land XML, and put points filter. We'll select our ground points. Okay. We're going to leave maximum number of points at 0.75. And now we're going to go set up a location where we want to save this. It's going to be our surface. True view 1, surface, file. Just click OK, and that will export your 10 file for you. Just click OK. And to export your contours, still under the Project tab, Export Wizard. Leave that at surface. You see we still have our ground points selected. Oops, my bad. This is reserve model key points. Let's change that to ground. Click OK. And cell edge, we're going to enter 0.1. Our attribute, we're going to uncheck elevation, check contours. Now we're going to check the contours tab. We're going to enter 1 contour interval. Next. Again, we want to limit this to our area of interest. Next. Click the ellipsis right here, go find a location where we want to save it. We'll create a new folder right here for contours. Click OK, insert attribute to map, and finish. There are our 1-foot contours. Change the colors of these. And if we go here to our File Explorer, got our contours right there. We're ready to take straight into your CAD software. And last but not least, you've got your tin file. Okay, this has been the LP360 ground classification workflow. Again, this is with, what version was this again? Version 25.2.2463.